All right, so here's some practice on solving systems of equations using graphing or the elimination method or the substitution method that was introduced today. So you have to do 6 through 10 because 1 through 5 was your quiz. So number 6. So in order to determine what method we use, we look at the equations. If both equations are in slope-intercept form, y equals mx plus b, then we can go ahead and graph it. Now that's assuming you have graph paper. If they aren't in slope-intercept form, but they still have an x and a y, then we can use the elimination method. That's where I'm going to get rid of either the x's or the y's, so again I can solve for that other letter, and once I know that solution, I can substitute it into the other equation and find the other variable. The thing we did today is with substitution. Substitution is a great method that I can use whenever one of my equations only has a letter, one letter. It's either going to be an x or a y. Because in those situations, I can actually solve for that variable. Remember, the whole key here is when you're finding the solution, your job is to get the x coordinate, which is a number, and the y coordinate. So we look at this. I'm going to do my same change opposite. I notice it's in slope-intercept form, so let's go ahead and graph it. Again, if you don't have graph paper, buy some, make some, print some, or go on the internet, find some graph paper, copy it, throw it into your paint program, and save it. And then your paint program can do graphing. Okay, so let's go ahead here. If you don't have graph paper, you can just sketch it on your paper that you're using. So I have -10, so that's right down here is my y-intercept. My slope is 4, so up 4 over 1, up 4 over 1. Okay, go ahead and graph that. Be accurate. Okay, the other one is y-intercept is 1. My slope is 1/3, so up 1 over 3, up 1 over 3. And you can see already that my graph intersects at one of the points already established. I don't even have to move my line anymore. Right there. Okay? So, the place where these lines intersect from their equations is called my solution. My solution is the ordered pair, which has the x-coordinate over 1, 2, 3, and the y-coordinate up 2. We know from working class that we want to check those. Whenever we do the graphing method, we want to check. So to check, we take our x and y, and we substitute back into one of these equations. Well, I don't want to do the fraction one, so let's substitute up here. So we know y is 2. We know x was 3. And we're going to add -10. So we have 2 equals, do your math, 12 plus -10. So 2 equals 12 and -10 is 2. And that checks out. So we know our solution was correct. So graphing is a pretty easy method. Again, the drawback is if my lines would intersect off the graph paper, and I can't make it larger, or they would intersect somewhere like in the middle of a box, and I wouldn't know the x and y coordinates. Okay, number 7. Well, if I look at those two equations, I notice that they aren't in slope-intercept form, so I don't really want to graph. I also notice that neither of those equations has only one variable. So that means I can't use the substitution method. I actually can't use that. So I'm left with the elimination method. So we know from last night's notes that we're going to rewrite it so that we can line everything up nice and straight. -x, I'm going to do my plus -y here, do same change opposite. There. Now we know from the elimination method that we can add these up. And what we're looking for is to cancel out either my x's or my y's so that I'm only left with one letter. Remember, the whole goal is if I have an equation with one letter, I can solve for that letter. and that would be half of my solution. That's your whole goal. Get one of the letters by itself equal to a number, and then you can substitute it into the other equation to find the other part. Easy stuff. So I got to get rid of either the x's or the y's. Well, how do I get rid of any terms? I have the opposites, right? So in this case, I have 5 and a -1. Well, they're not opposites. In this case, I have 2 and a -1. Can't do it. So I have to make opposites. So I always take the smaller coefficient, and I have to make it the opposite of the larger one. So you guys, right here, what's the opposite of 5? So I have to take the -1 and make it a -5. Or, what's the opposite of 2?
-2.
Or I could take the -1 and make it into a -2. It doesn't matter. Which do you choose? All right. So in order to make -1 into -2, what do I multiply by? -1 times what is -2? No. Oh, yes, you're right. +2. -1 times 2 is -2. Now, remember, you got to do it to everything. Okay, so my new system of equations is still the original one, 5x plus 2y equals 21, but now it's -1 times 2 is -2x, -1 times 2 is -2y, there you go, they're opposites, -9 times 2 is -18. Okay, what cancels? Yeah, these cancel, become 0. And there we go, 5x and -2x is 3x. We have only x's in the equation, so now I can solve for x. So obviously this is gone, and to get rid of the 3, I divide by 3. So what is x? 1. There. That's my x-coordinate. Okay, 1. Now, how do I find the y? Yeah, I substitute this back into one of them. Which one do you want? Okay, so let's put in the bottom one. Okay, notice that negative here? Okay, so I still have that negative, and then here's my x. What is x? 1. I use parentheses when I substitute. Then I have minus y equals -9. Let's do same change opposite. So I got to get the y by itself. So the opposite of -1 is? +1. They cancel. So I'm left with -y equals -8. Okay, I have to get a positive y. So what should I do with that negative? Yeah, and if I do it to this side where I change the sign, I just do it to that side. That's a nice little shortcut. So y equals 8. And there you go. There's your solution. Now I don't have to check this because I'm already using calculations. If I think I made a mistake, then it would be a good idea. But we just generally check graphing because then we're using a visual. And sometimes that's not as accurate. Okay, number 7. Oh, look at that. Well, we could graph that, and that'd be pretty easy, right? But what do you notice about this equation right there?
It's the y.
It's just a y. So I already know what the y is, don't I?
Yeah.
So look back at this problem number 7. Once I knew one of my letters, one of my variables, what did I do to find the other one? I just substituted it. Well, look at that. They're already telling me y is -6. So now how do I find x? Just substitute it. Thus, the method substitution. So, -6 goes where the y is. That equals 5/3 x minus 1. Okay, we'll do same change opposite. So we got to get the x by itself. Now, a lot of people want to get rid of the fraction. We only get rid of the fraction when we have those two equations. I can deal with one fraction in an equation with just one letter. The problem is when we have both those letters. So this is just a two-step. So I got to get rid of my -1, right?
Yep.
So add 1. They cancel. So I'm left with -5 equals 5/3 x. Right? How do I get rid of a fraction in front of a variable?
Multiply by reciprocal.
There you go. Multiply by the reciprocal. That's why we didn't have to do it earlier. We knew we could take care of it at the end. So I'm left with my x equals, okay, what's my sign? Negative. Okay. Divide. 5 divided by 5 is? 1 times 3 is?
3.
And there you go. And you're done. That's what substitution does for you. So substitution can actually be the easiest method. But it has to be certain circumstances. Okay, number 9. All right, well, what method are we going to do there? Graphing, elimination, or Substitution.
Elimination.
But aren't these both in slope intercept already? Yeah, we can't do substitution because I have y's and x's. Now, yes, I could go ahead and do elimination. But let's graph it. That just seems easier. Okay? All right. Here's my y-intercept, 5. My slope is 4, so up 4 over 1. And since I don't have any room, I'll go down 4 and over the other direction. Okay, draw your line. Make sure it's nice and straight. Okay, now do this one. My y-intercept is negative 8. My slope is negative 1/3, so that's up 1 and over 3. And notice what happens already. It already intersects at a place without even drawing my line. Okay? So that's kind of neat. Works out for us right here. So what place is that? That's over, what, over 1, 2, 3, over negative 3, and down negative 7. Okay, what do we want to do when we're graphing?
Good. Check.
Check it. So which one would be easier?
But it's all
Yeah, because it doesn't have a fraction. Good. So y is negative 7. X is negative 1/3. Oh, whoops. I'm sorry. I was looking at that. Y is negative 7. X is negative 3. And then I'm adding 5. Okay, let's see if this is true. Negative 7 equals negative 12 plus 5. So negative 7 equals what? Negative 7, isn't it? So that checks out. So that's correct. So we know that our statement was true, so that we know our solution is correct. All right, last one. Okay, well in this one, we don't have the equations in slope-intercept form. We certainly don't have one of the equations with only one variable. So no substitution, no graphing. So what method does that leave?
Elimination.
All right, so remember we're going to rewrite this. So negative x, do my same change opposite. So plus negative 7y. Okay, do the same thing here. Negative x plus 9y equals 23. Okay, well, let's go ahead and highlight our coefficients. I would actually make these into ones. I do that when I'm doing this type of work. Okay, then I have these. Well, are either of these opposites?
Yeah.
So, negative 1 and negative 1 aren't opposites, and negative 7 and 9 aren't opposites. So now, I have to make them opposites. Which you think is easier, the x's or the y's?
X.
Yeah, the x's. Because all I have to do to one of these is what?
Multiply.
What's the opposite of negative 1?
Positive.
So what do I have to do? Just change the sign. Have we ever done work where we just change the sign?
Yes.
Yeah, we did it right back here. If I change the sign of one thing, I have to change the sign of everything, correct?
Yes.
All right, so change this. Let's just do the bottom. Change that sign. So what do I do with this one?
Negative.
That becomes negative. What do I do with this one?
A positive.
That becomes positive. There you go. So now I have my negative 1x, positive 1x. What happens to them?
Cancel.
Good. So left is 0. Negative 7 and negative 9 is negative 16y. 9 and 23 is 32. Okay, we know that that's God. So, just solve your equation now. Y equals what?
Negative.
2. Okay, to find x, what's our method?
Substitute.
Okay, so let's just do the bottom. So I have negative x plus 9, and we know y is negative 2 equals negative 23. So negative x plus negative 18. And now we just solve this. This is a one-step equation, basically. Add 18 on both sides. They cancel. Negative x equals what? What is that? Negative. Come on, help me out. 5. Okay, oops. There we have a negative variable again. So what do?
Change.
Change change it. So if that becomes positive, what does this have? After this.
Positive.
So x equals 5. So what's my solution? What's my solution?
No. I
5,
negative.
-2. All right. Excellent work. Say goodbye.